Hi students, today we are going to discuss a new concept, that is lines of force and its property. So first of all, in the previous lecture we saw the different charges are there, and when the charges are at rest, then there is a field around it, and when the another charge is kept near to it, then it experiences some force of attraction or repulsion. So here again, with the similar diagram, we discuss the lines of force. Let us consider positive charge Q and negative charge Q. As we know, if the test charge is kept in the field of positive charge, it will repel, and we show the path of the charge when it is kept anywhere around the positive charge in this way. Similarly, if the test charge is kept in the field of the negative charge, we show all the lines of force lines which are towards the negative charge. What these lines or arrows represent? These are representing that the charge, test charge, when it is kept in the field, it goes away. It means that it is showing the path of the test charge, positive test charge, when it is kept in the electric field of the positive charge. And if it is kept, this test charge Q0, positive test charge, is kept in the field of the negative test charge, it will get attracted. So again we are showing by these arrows the path followed by the test charge when it is kept in the field of electric field of negative charge Q. So from this discussion we can conclude that what is lines of force? These arrows are showing the lines of forces. So how will define the lines of force? Lines of force is nothing but path followed by the test charge, when it is kept in the electric field of any charge Q. Any charge Q. Any charge Q means either it is positive or it is negative. When the positive charge is kept, then if the test charge is kept in the field of that, you will get the repulsive line, the lines which are away from the positive charge. And when the test charge is kept in the field of negative charge, you will get the lines which are towards the negative charge. So this is nothing but these lines represent the path followed by the test charge when it is kept in the electric field of the charge Q. Either it is positive or it is negative. So do you understand what is mean by lines of force? So lines of force is nothing but those lines. That is the pictorial representation actually, and these are imaginary line, and we show those lines from the positive charge away from it, and from the to the negative charge, those are close to the negative charge, or towards the negative charge. So after understanding this concept of lines of force, we'll go ahead and we will see what are the properties of these lines of forces. So we'll see here the properties. Of lines of force. To understand again, we'll draw the similar diagram here. Now suppose we are showing here, this is the positive charge, and then that time all the lines of forces we are showing away from it. So what should be the first property from this diagram? And if the negative charge is there, we are showing all the lines of force which are coming towards the. So the first property, we can say that the lines of force always present away from the positive charge and always present towards the negative charge. So if these charges are coming, if we want to show the lines of force, then those are always represented away from the charge positive, and always they present towards the negative charge. So this is the first property. Now the second property. To discuss this second property, again we have to draw one diagram. Suppose I am drawing this positive charge here, okay, and this is the negative charge, and here I am drawing the positive charge and positive charge. Similarly here negative charge and negative charge. So as we know, all the lines of force will go away from the positive charge. Here also we are showing, and here also we will show same diagram, okay, but now these two are near to it, okay. Here we can say these lines of forces will attract towards the negative charge, so it will go like this also. But if the similar charges are kept near to each other, then that time they will repel, and so the lines of forces are shown in this way. Similarly, if the negative charges are there, even though they are towards it, but they are repelling each other, similar charges repel each other, so the negative charge, if we are taking together, then we represent all the lines of forces in this manner, okay. So from this diagram we can conclude that now from this diagram, upper diagram only, we can conclude that all the lines of forces are produced from or coming from the positive charge and going towards the negative charge. All the lines of forces are coming from the positive and going towards the negative. From the positive they are coming, in short I am writing, and go towards negative. Okay. third property you can see here in the same diagram. So all these lines of forces to the negative charge we will show like this. Now here you can see all these lines are coming and coming from the positive charge and going to the negative charge. Now but if you'll see carefully, then you can see no line is intersecting each other. So the third property we can say they never intersect. They never intersect each other. Okay, fourth property now we will discuss. Now see here, if you will see here at this place, these lines of forces are crowding, and if you will see here somewhere, if these lines are going like this, so these are rarely spaced. So we can say now here at the charge these lines are crowdly spaced. But away from it, those are rarely spaced. Are you getting? So the fifth property now we will discuss here. Now you can see here this line, if it is from here diagram we can explain in a nice manner. Suppose the positive line, if it is giving this thing lines of force, and all these lines of forces are coming here, and it will go like this, isn't it? Now let us consider some of the line is going here and reaching. If one line don't want to go here like this, it will go like this, like this, like this, somewhere here, and it will go like this. But it is not happening in this case. It is following the shortest distance. Why? Because each and every line here is exerting some pressure on the another line, and due to this, and this pressure is called lateral pressure. Okay, each point on the line is exerting the pressure on each point of the line. So it is called lateral pressure, and due to this lateral pressure they follow the shortest distance. So in the fifth we will write here these lines exert lateral pressure on each other. Lateral pressure on each other. And sixth, we can say they follow the shortest distance. Why? Shortest distance. Due to the lateral pressure only, these are following the shortest distance. Okay, due to the lateral pressure only, they are following the shortest distance. Now this is the case similar to one case. Suppose one student is there and she follows the path from school to home. Okay, and this is her shortest distance. Now, but why she is following this shortest distance? Because some pressure is there. What type of pressure she has? The pressure of peer group or pressure of parents. It means that suppose she has having one friend, and that friend is all over around her, and she is observing all the activities of this student, and whatever she is doing in the school, on the way, all the reports she is giving to her mother. Now, if the friend of hers is absent, then that time what she will do? Because this student loves shopping, she loves to watch the movie and all. So what she will do when her friend is absent? She will definitely go to theater, she will definitely go to market or mall, and then after enjoying all those things, then she will reach here. When when the pressure is not there of that peer group or her friend, because now her parents don't know what she is doing, and that friend is also absent, and so she is following this much distance, and then she will go to home. But when her friend is present, she has to follow the shortest distance because of the peer pressure or the pressure of friend. Are you getting? This is for your understanding only. So same way here, because of the lateral pressure on at each point on the line, they are following the shortest distance. Otherwise they can also follow the longest distance over here. So it is all about the lines of force and its property. In this lecture we'll stop here, and in the next lecture we'll see what is flux and something about the flux. Okay, till that time, have a nice day. Stay safe. Thank you very much.